Hi there, everybody, and welcome. This is Professor Thayer. Today we're going to talk about your practice exam 2. This is for COMP112, Intro to Programming, and we will go over this in preparation for your test. So let me go ahead and share my screen. And here I've got your test up and also the answers that I provided for you. So the first page just goes through the instructions and the policies. So as you know, it's mixed mode, so there'll be paper and a code writing part. You should answer in a script for your code writing. It's an hour and 20 minutes. Please don't be using the things that we haven't learned about in the class to answer your questions, and there may be some questions that specifically ask you not to use something or just to solve it in a particular way. So do please pay attention to that. Of course, the honor code is in effect. This is an open note, so if you do want to take your notes with you to the test, don't forget to print them out if you have them electronically. You can't use the internet, especially ChatGPT, to answer your questions. Python built-ins we just mentioned. Please use the ones that we've discussed in the class only for the test. And there might be some different versions of the exam out there, so make sure you answer the questions that you got. All right, so let's get into it. The first part of the exam is the closed response part. This starts off with some true and false questions. So in the first question here, oh yes, and by the way, I have the answers up right over here. You also have this script available to you on our Google Drive. The first question has three variables, A, B, and C, being assigned to integers, and then the list collects those three, and now we're checking whether the variable A is in L, which in fact it is, so that will return the Boolean true, which maps to T for true and false. In Python, integers are objects. Pretty much everything is an object, so that's also gonna be true. Question 3, we have a dictionary being defined here, and then we're adding another entry in that dictionary. We're asked to print the dictionary, and then we print whether eins is in D. Now, remember that using in will only search the keys. Now, this is a key value pair. So eins is a value, and using in will not find it. So 3 would be false. So even though technically it is in the dictionary in English, it's not in there according to Python because in will only search the keys. The next question says a valid Python list must be homogeneous. So while homogeneity is something that we enforce in the class for practical reasons, that is not a condition of Python, strictly speaking. So that is false. You can have a heterogeneous list, although it's not advisable. All right. Section B is the multiple choice. So which of the following are mutable? List string attribute of an object. They're all mutable, or only A and C are mutable. So in this case, we want to look closely. Lists are mutable. Strings, however, are not mutable. Remember, we first encountered mutability with lists for that reason. And we did mutate attributes of objects, like we changed the value of X. So that means A and C would be mutable. So that would be answer choice E. And let's just make sure, yes, that all matches. Good. Next up, we are going to take a look at this expression that will create this. Which of the following expressions will create an object of type list? Okay, here we're using the list coercion, here we're using the square brackets, and here we are creating a list with multiple entries in it all at once. This is a heterogeneous list, but that doesn't make it invalid, as we already said. So these are in fact all Python lists. These are different ways you could create a list. This choice E, none of A, B, and C, because lists are objects, so that's not right. The answer is D. Okay, and finally we have question number 7 in this section. Which of the following are true about dictionaries? The order of the entries may differ from the order in which they are entered at its creation. Yep, that's true. There may be duplicate identical keys in different dictionaries. Yes, it's okay to have them in separate dictionaries, not in the same dictionary. A key can map to a list of lists. No, that you cannot do that because you need multiple brackets to get the list of list entries out. This says all are true or one of the items is false. So I am going to go with E, that one of the items is false, because I do not agree with C being true. All right, next we will take a look at the short answer questions. All right, so we have the short answer questions over here. Now, I was just going through this test again myself, and question number 8 is definitely the most challenging one in this section. So actually, I wrote all this code for question number 8. For a short answer question, it's kind of involved. So one of the things you definitely want to do is check to see if you have options to skip questions. So select 5 of the 8 questions in this section. So this would definitely be one of my key questions I would be thinking about skipping. But nevertheless, it is a solvable and fair question, but let's take a look and see what it says. Write a function called strand that takes a string, that's the str part, and rand is the random part, and randomly removes a letter from that string and returns it. Sounds like pop. If the empty string is provided, it should return error empty string and return the empty string. Note you may wish to use the random for this problem, which I do recommend. Some sample outputs are shown. Please include these test function calls in your code to run your function. So here we have some samples where we're going to do strand of ABC, and then this one is cycling over the strand of A and B. So the idea is that one of them would get removed and then it wouldn't have anything, it would become empty. In range 2, this will go up to but not including 2. So this cycle recall would only take 1. Here we're testing what if we send in an empty. So remember that you cannot mutate a string, but what you could do is coerce it into a list, which is the way I recommend doing this. So here I have the first version of my strand. This is going to take in L, so it actually is, oh, sorry, actually this is wrong. Actually, at this point, it is a string. You could use a list. I guess that's why I put that there. But the question clearly says you should use a string, and that's how it's being sent in here. And it's returning a string. In fact, actually, that string would be just a character. So if length of the list is greater than 0, right? If it's not, it's going to handle this error situation, right? Return error empty string. Here we're going to coerce L into the list so that it will be mutable. And then what we're going to do is we're going to select out an element by using the random dot choice of the items in L. So in other words, it chooses a random letter in the original string, which is now in the form of a list. And then we can use remove to take the element off, and we know what element is, so we can return element. So that's one solution to this. Here are the tests down here. And you may have also done it a slightly different way. So I was thinking of pop actually when I was reading this question. So I also wanted to solve it this way. So in this first way that I solved it, it's more about solving it with the removing the actual item, but you also could randomly select a numeric integer and then you could pop that integer. Of course, when you make your integers, you're going to need to be mindful that you don't go off the edge of the list so that you will not generate an error. So this has the same basic setup of if the length is greater than 0, and if not, we catch that case with the else. It's going to report back the empty string. And then again, we have the coercion into the list, and then we're going to use random dot choice up to the range of the length L. So this will randomly select integers that are in the range of 0 up to but not including the length of the string. So these should match the indices of the items in the list. And then IDX will collect whichever one that is. And then what we will do here is we will pop that off. So remember that when you do L.pop, what will happen is that it will select the index you provide, and then it will remove that item from the list, and that gets returned. So that gets returned into return. So that means, in other words, the thing that got popped will be returned by this strand2 function. And so then that pretty much concludes this. So this will then be our test for that section, and we can demonstrate that either of these solutions would work. That's a lot of work to do for a short answer question. One of the best things you can do in a short answer is screen them to make sure you have chosen something that can be answered in a reasonable amount of time, and it may benefit you to be able to pick those things out. I mean, it does give you more choices, so that was not an inordinately difficult question to answer, but it was a little bit long, especially for short answer. All right, next up, let's take a look at question 9. So this is a question about dictionaries. Show 3 ways to create the dictionary shown. So this is sort of like the list question that we had. So here is a couple of different ways that we could do it. We could create it all in one fell swoop. We could use the dictionary command and then put the entries in, and also we created an empty dictionary and then sequentially added each of the entries. So those would be 3 obvious ways. You could also do other combinations. You could create a dictionary with 1 entry and then add 2 more. You could create it with 2 entries and add 1 afterwards, or I don't know, make a dictionary with too much stuff and take 1 out, or whatever. So there's a lot of different ways you could do that. All right, the next question is object-oriented fill in the blank. So there is a nice little word bank over here. And let's see if we can get all of this in the screen. All right, so yeah, the instructions: use the words from the word bank and fill it in. So it does also give you instructions. You're allowed to skip some pieces of this question specifically. So that means if you choose this question and you're not sure about some answers, you can get an out for that. So again, it's nice to just keep that in mind. All right, so this is a class snack. We have an initialization, and here is all of the initialization occurring. And here we also have the price per size. And it will compute the unit price of the item. And we have now the instantiation of a couple of snacks. We have some chips and we have some candy down here. And now we have a word bank. And this is our little paragraph about the snacks. So let's see. The something snack is a template for Python objects. This would be the class snacks. So that would be class. That would be choice D. The init something has a property that it executes each time the class snack is called to assign the arguments as 3. So this would be a special method which we recognize because it's got the double underscores by it. So we have init and we have add and we have sub and stir. Those are the main ones that we have seen. There are also others. And 3 is going to be attributes. As attributes to the object as it is 4 instantiated. So as this is actually, is the instance is actually created, then this will run and assign those values. 5, the 5 price per size, that's this one right here, does not have double underscores. So this one is going to be a user-defined method. So that choice would be 5. It would be method. Is called during the dot notation and computes the unit price for that object itself. The 6 is used to indicate that the attributes will be used associated to that object, which were created by init. 6 sounds like self. Yes, that is the idea of putting it back onto itself. The attributes, however, are 7, mutable. So they may obtain new value throughout the execution of the code. So that means that they could be changed. That's exactly what we mean by mutable. So this is the clue. They may obtain a new value throughout the execution. That's how we get the clue for mutable. The chips and candy are examples of 8 of the class snack. They are instances of a snack. So this would be instances. There are instances of the snap. Yeah, it kind of is self-explanatory right there. All right, very good. So that's the fill-in. Now let's move on to the next one. Yes, we're going to use the directory tree. So I'm going to try to get the directory tree into view here. It starts up at root. This one is the road not taken. All right, so a snippet of an interactive session is shown. Blank line indicates where some code is missing. Provide the missing code. So we begin by listing the directory and see that project 1 and project 2 are given. So this means we must be in the directory mark 01. Then we see that something happens and we list a directory and results 1.txt is shown. So what this means is we must have changed directories to Theodore because results1.txt could only be in Theodore. There's no other choices for that here. So we'd need to do os.chdir, and here is the path to Theodore. Notice that it is in the quotes because it should be type string. All right. Next, we have another part here, absolute operating system, right? A function cd that will change directories to mark 01 and print the absolute path to all files within that directory. Your function should work from any location in the tree. Do not call the function because it's a fictitious tree and you will generate an error. Yeah, actually, let's see, I didn't actually write out the function, but basically you would just put os.chdir. So this is changing the directory, and then you would also do os.listdir in order to list out the content. So you'd have a function with just those two lines, and it would return none type, and also it doesn't need to take anything in because it does only very specific tasks. It does not take any variable paths or anything else. All right, so next, method function both or neither. Indicate if the characteristics describe method, function, both, or neither. Typically includes a reference to its own object instance as its first parameter. Now this means self, right? So the only one that takes self is the method. So that is an M. May produce an output or not, depending on how it's written. So this is about returning. So both methods and functions are capable of returning something, so we would need B. We know this because they both need to get doc strings. Can belong to a class as part of its definition. So functions inside of a class become a method, so this is really only a method, right? So, because functions belong in main. Okay, can access attributes defined during initialization without requiring them to be passed again as arguments. This is because of the dot notation, because in the methods we have the attributes which it can access. So this is a D should be only for a method. Can exist in the main body of a program. If a method is not inside a class, it won't be valid. So you would need to convert it to a function. So the only one that can exist in the main body of a program is a function. And finally, be invoked from inside another callable unit of code. You can call either methods or functions from other methods or functions. That's fine. So that would be both. So these are a little summary of the answers for question 13. All right, the computer scientist spotlight matching is taken directly from the beginning slides of each of the lectures. So just to match these up, Alan Turing is credited with inventing the universal computational model, the Turing machine, and the scientists laid the foundation for modern computing theory. That's Alan Turing. Alan Shugart developed the IBM disk, innovated the revolutionized how personal and commercial computers handle data. They used to hold them all on in transient memory before that. Okay, co-designed groundbreaking programming language that introduced the concepts of classes and object orientation. That is Kristen Nygaard. We talked about a couple of people who had been involved in object-oriented programming and helped advance early compiler technology for Fortran at Hewlett-Packard, breaking barriers for African Americans in Silicon Valley along the way. This was Roy Clay, and Fortran came out in 1977 and is the first language I learned how to program. All right, and number 15 is about init. In Python, the class is defined The classes often define a method called init. You should always get in the habit of using init. What's the purpose? This is what sets up your attributes in your class. And what does the keyword self represent inside this method, and why is it necessary? It represents the individual instance of the of an object, right? So and what it does is it puts the attributes onto that instance of the object. This is what allows us to have multiple objects that have the same attribute. Like with car lot, we had make, model, price, color, and so on for each of the cars. So it's that self that allows us to do that, and the attributes are added during init. All right, so that is the end of the paper part of the exam, and we move on to the code writing part. So again, you had some choices as to which ones you could skip, so you yourself may not have answered all of those questions, although in preparing for the exam, you might opt to do all of them just after you've completed the timed version of this. All right, let's take a look at the code writing. So again, you do have some choices here, so I would take a look at the questions and choose which ones seem like the most easiest ones to answer, or which ones are most familiar to you. So what we're going to do here is have a lighthouse themed question. The first one is set up a data file. Use Python to write a text file containing the information shown. Insert your working directory. From the command line, print the contents and copy the output. So these are some lighthouses from Cape Cod, Massachusetts. So here we have a couple of lighthouses, name, town, year built, the blink rate, and their height. So that is the information that we have available here, and looks like it is separated by the colon up to this point, and then this rest of the data is following that. So here's an example of doing this. So here we're going to open the file in status W, and we're going to use f.write to verbatim put this information into the file. Part B is Lighthouse Dictionary. Write a function, make Lighthouse Dictionary that returns a dictionary with information about the lighthouses read from part A. As you read the file, populate the dictionary with the name of the lighthouse, key and town, the year of built, signal, and height values is stored as a list. The key should be mapped to a value that is a list of length 4. All right, so if you did not create the file in part A, you can just pretend that it exists, or you might also just like verbatim paste the information instead of having Python write it. So you can do this question. So here it's taking no input and it's parsing a file into a dictionary. So this function creates the empty dictionary. It opens the file. So here's our open command, and we're doing this in status read. Now we're going to need to loop through this. So we're going to do for line in the file. It's going to do the stripping, and then we are going to do the splitting using the colon. So very conveniently, that is going to split exactly as we had been asked to split the data. So here what we're going to do is we're going to have name is parse 0, town is parse 1, and the rest will be parse 2, which we can then split based on the spaces. So then we could combine this whole thing in. So here we have the lighthouse name, and then we have the elements of the list just as is requested. Don't forget to close your file, and then we're going to return the dictionary. So here is our return. All right, next is lighthouse validation. Write a validation is lighthouse that takes a string as input and a dictionary and returns true if the lighthouse is in the dictionary, otherwise it returns false. So here we have the input for name and dictionary is lighthouse is the name of our function. It's going to return a bool. Oh, I see, I didn't complete my signature here. I'll fix that. All right. And so then if the name is in the dictionary, so remember we can use in to check the keys, so this will work great. So if name is in the dictionary, it will return true, otherwise it returns false. So as it turns out, this one was actually pretty easy. And then here are some samples of testing this out. All right, next one is lighthouse info. So we're going to write a function lh info. sometimes people have a difficult understanding what this is, that maybe I should have made that a capital L for lighthouse. But anyways, it's not the number one. That's LH for lighthouse, because one would be invalid. Takes the name of a lighthouse as input and returns an informational paragraph of the lighthouse. And we have some sample text down below so you see how it's reading. So essentially what we're going to do is we're going to just substitute in some values. So we're going to pull the values from the existing dictionary. Now, if you use Python to create the dictionary, that's great. If you didn't do that question, you could simply just verbatim make the dictionary yourself, or you could just imagine it, and that's fine for this question. So here we're going to build the paragraph using the concatenation. So we simply just take the information that is provided right here to get the text. So we're going to substitute in the name, and you'll substitute in the various information. So the name, info, the town, the year, the height, and so on would be concatenated together. And we've just added this to a growing string called message. And we'll simply then just return the message. You can use the /n if you want to have it have nice new lines in there. It will still only be one message. And this else block will branch will take into account if the name is not found, and it will say that it's not in the database. So here's some examples of what that would look like. All right, the next one is the object-oriented lighthouse question. So this will create a class lighthouse with attributes name, town, year, blink, and height. The class should initialize objects when called, which indicates that we're looking for instantiation. So we need init. So here is the class lighthouse, and here is our init with the various requested information. Here we have the signature on it. I could also be more complete and put none type on the end of this, because this does not return anything substantive. And let's see, we could have a two-parameter, object-oriented lighthouse, initialize the object, instantiate any two lighthouse objects of your choice. So here are some lighthouse parts down here. Now notice that these questions, especially the object-oriented ones, require you to put the code in specific places, and this may sometimes be out of order with how the questions are asked. And that's fine. And if this comes up on your test, don't worry about it. You should simply just put the parts where they belong in terms of what object-oriented programming says. See how I just labeled this one here, part E, so that I just knew that that was the continuation of part E so that I can find it. So when I'm looking at your tests, I will just look for the pieces in the place where they're supposed to be. So don't worry about the questions being a little bit out of order for that. Now, part F. Configure the behavior of the lighthouse objects when they are printed to display the name of the town, year, blinking pattern, and height. Create a test to the lighthouse objects. Show the output as a comment. See in here we have the note. Please place this code appropriately for it to be functional and label with the comment. Use one of your lighthouse objects. Show the test of your code. So to print the lighthouse is suggesting that we should be doing stir. So this right here, we could even label more. Clearly, we can see that that's going to be part F. Using the pound and a comment after that is a good way to do it so that you don't mess up your indentation, because that will matter for your object-oriented. So here is the stir to do the printing. So this is basically a pretty long way of just saying that we need to do that. All right, here is an example of printing for F. And again, you see that that needs to be down below. So we have that over here. And then add lighthouse. Behaves like a built-in append method. The function should take two parameters, list and name. Should add the new lighthouse name to the end, and using the list operation, no use of append or extend, and return this. All right, I am going to, one sec, put this. I need to go get that code for you. 1 second. All right, sorry about that. I just needed to go grab that code for you. So we were taking a look at this final question at lighthouse. So we're going to put this in as a method here. So this is section G. So this is going to take, no, this is wrong. This is going to take This needs to take self and a list, and that's it. Yes, this is correct. So this is wrong because you don't need a string here. It is self. Sorry about this. That's better. So just trying to make this a little more clear. All right. So this has self and a list. And then what we're going to do is we're simply going to just concatenate on whatever lighthouse we call this by to a self dot name, right? So what this will do is it will take its own name. So if we notice, the one that we're looking for is Nauset Light according to the question, which is actually Lighthouse 1. So if I do lighthouse 1 dot add lighthouse, so I call this method using lighthouse 1, it will use self dot name. And what is the name of self dot name? Oh, it's Nauset. So I don't even need to make another lighthouse. So then I will have this list. So I just took this from over here and created the list of some lighthouses. And now I'm going to supply the list up here. So this needs to go into the add lighthouse. Notice that I don't need to pass in my own lighthouse because I'm going to get it with self.name. And then I'm going to add the item onto the list. So I'll do list plus equals. So it adds the next item on self.name to put all of this into the next entry. And so we basically just use concatenation for lists. And when we do that, then we get out that item in the list. So let's go ahead and just run our module just to make sure that everything is working. All right, so we had some prior questions and I can almost see it, but it's off the edge of the screen here. I should be able to see my lighthouse list, and it is right here, and Nauset is added onto the list. All right, well then, I hope that was helpful to you to go over the exam. That should give you a sense of the kinds of questions that will be on the next exam, and hopefully give you some ideas on what you might want to brush up on before the test. Hope you have a good night and happy studying, and we'll see you next time. Thanks so much. Bye-bye.